We all know that acceleration is the rate at which the velocity of an object changes with respect to time. However, do you know what is uniformly accelerated motion?
It can be difficult to perceive how an aspect that is defined by a rate of change can be defined as uniform.
Let us study such uniformity in acceleration in detail, especially since it is a vital concept that is necessary.
But before we head to our formal discussion, let us first define kinematics. Well, kinematics is a branch of classical mechanics that describes the motions of points, objects, and system of groups of objects, without reference to the causes of motion. For the information of everybody, the study of kinematics is often referred to as the geometry of motion.
There are types of kinematics, namely uniformly accelerated motion, free-form motion, and projectile motion. However, in today's video, we are only going to focus on the uniformly accelerated motion.
One can say that uniformly accelerated motion is a motion of an object where the acceleration is constant. In other words, the acceleration is equal to a number and that number does not change as a function of time.
Examples of uniform accelerated motion include number 1, an object sliding down from a slide, number 2, a ball sliding down from a steep slope, and a person skiing.
But wait! Keep in mind that these examples of uniform application do not maintain absolute uniformity of acceleration due to the interference of gravity and/or friction. However, these are still some of the cases where acceleration will be uniform if gravitational force and friction is considered zero. Moving on, here are the following equations to describe an object in uniformly accelerated motion. First, Vf squared is equal to Vi squared plus 2 times A times d. Second, Vf is equal to Vi plus A times d. Third, d is equal to Vi times d plus 1/2 times A times d squared. And lastly, d is equal to Vf plus Vi over 2 times d, where Vi is initial velocity, Vf is final velocity, d is displacement, A is acceleration, and t is time.
Now, let us apply this kinematic equation in solving problems involving uniformly accelerated motion. Example number 1. If a race car takes 3.58 seconds to get from 20.7 meters per second to 48.5 meters per second, what will be the distance traveled of the car? First, write the given. The time is 3.58 seconds, the initial velocity is 20.7 meters per second, and the final velocity is 48.5 meters per second. Based on the given, choose the appropriate formula to be used. And since the displacement is the missing value, d equals Vf plus Vi over 2d is the appropriate formula to be used in this problem. Next, substitute the values and apply the operations. 48.5 meters per second plus 20.7 meters per second is 60.2 meters per second. Divided by 2 is 34.6 meters per second times 3.58 seconds is approximately equal to 123.87 meters, which is the final answer.
Let's proceed to example number 2. Over a distance of 37.1 meters, a bike gradually gains speed from rest to 9.33 meters per second. Identify the acceleration of the bike. First, write the given. The distance is 37.1 meters, the initial velocity is 0, and the final velocity is 9.33 meters per second. Based on the given, choose the best formula to be used. And since the acceleration is missing value, Bf squared is equals to Bi squared plus 2Ad is the appropriate formula to be used in this problem. Next, substitute the values and apply the operation. 9.33 meters per second squared is equals to 0 plus 2a times 37.1 meters. So 9.33 meters per second squared is 87.0489 meters squared per second squared. is equals to cancel the 0 since it has no value plus 2a times 37.1. Bring down 87.0489 meters squared per second squared is equals to multiply the distance by 2, which is 74.2 meters a. So now, we need to crush out the distance so that the acceleration will remain. So, 87.0489 meters squared per second squared over 74 meters is equals to 74.2 meters a over 74.2 meters. Crush the same unit, then divide. So the answer is acceleration is equals to 1.17 meters per second squared.
For example number 3, in 3.27 seconds, a car going 25.1 meters per second skids to a stop. Identify the skidding distance of the car. First, write the given. The time is 3.27 seconds. The initial velocity is 25.1 meters per second, and the final velocity is 0 because the car skids to a stop. Based on the given, choose the appropriate formula to be used. And since the distance or displacement is the missing value, distance is equal to final velocity plus initial velocity divided by 2 times time is the appropriate formula to be used in this problem. Next, substitute the given values and apply the operation. 0 plus 25.1 meters per second is 25.1 meters per second. Divided by 2 is 12.55 meters per second times 3.27 seconds is approximately equal to 41.04 meters, which is the final answer.
Example number 4. How far could someone run if they started off walking at 1 meter per second and then to 5 meters per second within 30 seconds? First, write the given. The initial velocity is 1 meter per second, the final velocity is 5 meters per second, and the time is 30 seconds. Based on the given, choose the appropriate formula to be used. And since the displacement is the missing value, distance is equal to final velocity plus initial velocity divided by 2 times time is the appropriate formula to be used in this problem. Next, substitute the values and apply the operations. 5 meters per second plus 1 meter per second is 6 meters per second, divided by 2 is 3 meters per second, times 30 seconds is approximately equal to 19 meters, which is the final answer.
For example number 5, a plane requires 1,465 meters to travel at 90.4 meters per second after takeoff. Determine the acceleration of the plane and the travel time required. So, here are the given. Distance is equal to 1,465 meters, initial velocity is equal to 0, final velocity is equal to 90.4 meters per second, and we need to find the acceleration and the time. The formula that we will use to get the acceleration is Vf squared equals Vi squared plus 2AD. After inputting all the given into this formula, it will now be 90.4 meters per second squared equals 0 plus 2 times 8 times 1,465 meters. Squaring the final velocity will result to 8,172.16 meters squared per second squared, and then multiply 2a and 1,465 meters, which will now be 2,930 meters a. After that, divide both sides by 2,930 meters to cancel like terms. After that, divide 8,172.16 meters squared per second squared by 2,930 meters, and our acceleration is now equivalent to 2.79 meters per second squared.
After determining the acceleration, now is the time to find the time. To find the time, we are gonna use final velocity is equals to initial velocity plus acceleration times time, since this is the appropriate formula to be used in this problem. Next, Substitute the values and apply the operations. The final velocity is 90.4 meters per second, equals to the initial velocity, which is 0 plus the acceleration, which is 2.79 meter per second squared, times time. After multiplying, you'll get 90.4 meter per second equals to 2.79 meter per second squared. Now divide both sides by 2.79 meter per second. Then crash out the same values as well as the same unit. Then you'll get the time, which is 32.40 seconds.
So, that brings us to the end of this video. We hope that you learned something about kinematics, particularly the uniformly accelerated motion. That will be all, and thank you for listening.